for a real valued x such that this radical equation holds. Now, a lot of you will note that it's in the form u cubed minus u equals to 20, what is this number, 26,970. And of course, the substitution is when u is equal to the square root of x. So already, that's an approach. You have this large constant out here, and this is just a third degree polynomial, so you could do the rational zero theorem by just rewriting this as u cubed minus u minus 26,970 equals to 0, right? And so again, this is I'll call it standard. In school, you don't really see homework assignments with this big a constant. So the whole task here is to find out what type of divisors of this number are going to satisfy this, if any. Now, the problem does suggest there's an answer, but so let's move along here, though. And I chose not to do it this way. It ends up being sort of the same thing, but we'll see what you think. What I did is factor out a square root of x, right? But then you can write x minus 1 is the square root of x plus 1 times the square root of x minus 1. So it's the difference of two squares in a slightly uncommon form, all right? Now what we have right here is three consecutive numbers. Now, we don't know if they're integers necessarily. One would be led to believe that they're probably integers if there's going to be a solution. But we have three consecutive integers. If these are irrational numbers, you don't really think of them as being consecutive, right? They're just one apart. But if this happens to be integers, we have three consecutive integers, minus 1, the integer itself, and then plus 1. And the integer itself would be the square root of x. So we're rooting for an x that is a perfect square, of course, on these type of problems. All right, so again, we're looking to determine if the constant 26,970 has three consecutive divisors. So let's get busy looking at this. It's clear that 26,970 has divisors 2 and 5, right? Because it ends in 0, right? And 2 times 5 is 10. So 2 and 5 are definitely divisors. Notice that the sum of the digits here, 2 plus 6 plus 9 plus 7 plus 0. Okay, what does that equal to? 16, that's equal to, I left out the 0, but that's equal to 24. And 3 divides 24, right? So that's a very well-known result for divisibility. 3 divides 24, clearly 3 times 8 is 24. Okay, so we have 2, 5, and now we have 3, right? So we at least know the biggest divisor that we know at this time would be 30. 30 is a divisor, right? Without doing too much heavy lifting. All right, so there's not a whole lot of computational challenge to this at this stage. All right, so we have SOR divisor. All right, now, so since we know that 30 is a divisor of this big number, we can, and this is not hard to do mentally, and I'll see if you guys believe that. 269 70. I don't know why it does that. It does a disappearing act. Okay, so we have 26,970 divided by 30. And if you just kind of forget about the zeros here, it's not hard to see that this is 899. Right, folks? You'll agree no calculator required there. Okay. 3 times 899 is 2,697, and then you have the 0 on there, right? But also notice a very cool thing here. 30 minus 1 times 30 plus 1 is equal to 899. Again, no calculator required, right? Why is that so? Well, it's our famous difference of two squares result, right? That's 30 squared uh, minus 1, right? 30 squared minus 1 is equal to this object, okay? But what is this? This is 29 and 31. So we have it. We have 3 consecutive integers that are divisors of our big number, 26,970. And so what we can do, folks, is just line them up right here. Remember, these happen to be integers, so they're consecutive in the sense. You don't think of consecutive real numbers in any sense because they're continuous, they're dense. But so you have 29 right here, and any one of these is going to solve the problem. 29 would be this integer, 30 would be this integer, and 31 would be this integer. Okay, and again, we still don't know if it's going to work out, but we can see that it will, because if we set the square root of x equal to 30, that certainly implies that x is equal to 900, which is our solution. And as far as I know, it's the only solution. It's a kind of a strange problem. What did I say, 900? Yeah, 900. X equals 900 is a solution. Now you may be saying, well, is my way better? And I'm not claiming it's better. It's just it's kind of a change of pace. Variety is the spice of life thing. Everybody's seen this kind of thing before, where you list all the divisors. By the way, the divisors of this, you could find them. It's 2 times 3. We've just done this, but I'll just write it down. 2 times 3 times 29 times 31. Okay? Now, all these are accompanied by exponents of 1. And you guys may remember there's 5 of them, so there would be 2 cubed total divisors. 2 to the 5th, excuse me. 2 to the 5, folks, equals to 32. Basic combinatorics results where you can count the divisors that way by having the prime factorization, then incrementing each of the exponents and then taking that product will be the number of divisors. Okay, so 2 to the 5th is equal to 32. There's 32 divisors. We were just fortunate enough to discover the 3 that we needed to make this thing work. All right, the 3 that we needed are 29, 30, and 31. All right, but they would be 3 of the 32 divisors that existed. And that's the task you would be faced with if you were just trying to treat this as the u cubed minus u equals 0 polynomial, and then do the rational root test. Okay, the rational 0 test. Okay, so again, I think this way of finding the prime factorization is a little bit easier. It's not always so easy to find the prime factorization. So I'm not saying one way's better than the other, but this way gets it done pretty quickly based on some pretty well-known divisibility tests and some fairly routine arithmetic. Okay. All right, so x equals 900, I think, is the only answer to this problem. Notice this left-hand side always has to be positive. I don't know if there's any I'm not sure even how to figure out if there's any imaginary, I guess you could use, you could use synthetic division. Once you know that 900 is a solution, you could go through and do synthetic division and get this and see if there's any imaginary. There may be some imaginary. But you got to be careful, because you see your u is equal to the square root of x. So that, to me, that slightly, confuses things just a little bit. But we do know that 900 is an answer. All right. Thanks for viewing.